Hello, my name is Justin McMillan. I'm a research and development engineer at Applied Research in Acoustics, or ARiA, and today I'm going to present some very promising technology in the field of active sonar. Specifically today, we're going to be looking at deep learning and how it can be used for the detection and classification of target clusters. First, a little bit about us. Since 2010, ARiA has combined the skills of world-class research scientists with experienced software and systems engineers to bring bleeding-edge technology into the field. With over 60 years experience in signal processing, 35 years experience in software development, and 25 years experience in machine learning and deep learning, our team consistently gets more done faster and for less. Our objective for this project is to develop algorithms which learn contextual representations of complex spatial and Doppler structure to improve target cluster detection and classification. By forming predictions based on these representations, we are aiming for a 50% decrease in the rate of false track formation without sacrificing tracks on target. This reduction translates into a significant reduction in operator workload as well as staffing requirements. Once fielded, the next generation cluster, or NGC, is intended to augment and improve existing detector classifiers in active sonar systems. While the primary target is the ANSQQ-89, platforms such as the Littoral Combat Ship, the Constellation-class frigate, and the P-8 Marine Patrol and Reconnaissance aircraft would each benefit from the improvements in target detection and tracking. So what is the next generation cluster? At its core, NGC is a neural network, optimized for detection and classification in sparsely populated, information-starved sonar environments. When the signal from a ping is fed to the network, it is transformed into a set of features, which are learned during the training phase. The transform signal is then divided into a spatial grid, and several predictions are made within each cell, each consisting of confidence that the contained energy represents a target, the estimated target type, such as surface, subsurface, clutter, and the coordinates that bound the prediction. Once the entire grid is populated, overlapping predictions are consolidated based on target likelihood. NGC takes as input the same data as existing energy detectors and is designed to either replace or augment predictions generated by the current processing string. This both reduces the effort required to integrate NGC into existing systems and drastically reduces integration risk. Currently, NGC is at a technology readiness level of 5. Having been validated in a relevant environment. For a period of performance beginning in February 2021 and ending in February 2023, 2 of the 3 major milestones have been achieved, and completion of the final one is in progress. Development of the initial prototype has been completed, and the improvements conferred by a more mature prototype over the SQQ-89 baseline were presented to the Active Sonar Working Group in October of this year. This Step 1 evaluation has been improved, and we are working with maintainers of the current processing string to develop an independent Step 2 evaluation framework. NGC's key features include a neural network-based feature extractor and core detection algorithms, new engineered feature classification features, and feature fusion architectures for leveraged learned and engineered classification clues. NGC's neural network architecture confers the advantage of acoustic context and the benefit of improved rejection of structured clutter. New engineered classification features improved classification performance, and feature fusion architectures enable use of new engineered features as well as those developed over decades by the community. The initial transition target for NGC is the pulsed active sonar functional segment of the SQQ-89. We have completed an early Step 1 brief to the active working group and are working with them to complete a Step 2 evaluation targeting the ACB-25 build. Secondary transition targets for future builds include the LCS and FFGX. Other platforms that could benefit from NGC's clutter reduction capabilities include the PMA-264 anti-submarine warfare air systems and platforms using continuous active sonar. The initial transition target for NGC is the pulsed active sonar functional segment of the SQQ-89 with secondary transitions to other IWS-5 ASW platforms, including the LCS, FFG, and continuous active sonar systems. Resources needed for transition include support for integration and a Step 3 T&D. We plan to coordinate integration with ARiA's and L3Harris, who developed the functional segment, as well as Lockheed Martin, who developed the system. Come chat with us. We can be reached via email or phone, and we have engineers in 3 time zones. So chances are at least one group of us aren't bothered by questions sent at odd hours.